Picture this, a star so colossal it makes our sun look like a speck of dust, a celestial titan burning with the fury of a million suns, warping space itself with its sheer gravitational might. This isn't science fiction, it's the reality of supermassive stars, the universe's most extreme and enigmatic giants. Right now, across the cosmos, these stellar behemoths are performing acts so bizarre they defy everything we thought we knew about how stars behave. Some vanish without warning, others pulse like cosmic heartbeats. A few might even be hiding secrets that rewrite the laws of physics. Over the next few minutes, we'll count down 30 of the most mind-bending, head-scratching, and downright terrifying behaviors of these astronomical anomalies. From stars that eat their neighbors to ones that mimic black holes, each revelation will make you question what's really possible in our universe. So buckle up, we're about to take a journey into the strangest corners of stellar science, where every discovery raises more questions than answers. And trust me, by number 15, you'll be seeing the night sky in a whole new light. Now let's zoom in on one of the most jaw-dropping behaviors of these cosmic giants, runaway hypergiants. Imagine a star so massive, so powerful, that it tears itself free from the grip of its own galaxy, racing through space at speeds that defy logic. These aren't just fast-moving stars, they're stellar fugitives, ejected with such force that they leave entire star systems in their wake. So what could possibly launch a star this big into such a chaotic escape? One leading theory points to violent encounters with supermassive black holes. Picture a hypergiant wandering too close to a black hole's gravitational pull. The star might not get swallowed whole. Instead, the black hole's immense force could slingshot it outward like a cosmic catapult, sending it hurtling across the galaxy at hundreds of thousands of miles per hour. Another possibility, explosive breakups in binary star systems. If one star in a pair goes supernova, the sudden blast could kick its companion star clear out of orbit, sending it rocketing into the void. And in rare cases, dense star clusters might fling hypergiants outward through gravitational chaos, like a game of stellar pinball with unimaginable stakes. The strangest part, these runaway stars don't just vanish. They blaze trails of superheated gas, leaving glowing scars across the cosmos. Some even drag smaller stars along with them, creating rogue stellar families adrift in the darkness. It's a reminder that even the mightiest objects in the universe aren't always where, or what we expect them to be. And if you think that's wild, just wait until we explore the next mystery, stars that flicker like dying light bulbs, dimming in ways that still leave scientists utterly baffled. Now let's turn our attention to another cosmic head-scratcher, stars that seem to play tricks on us by fading in and out like a flickering candle. Take Betelgeuse, for example. This red supergiant, one of the brightest stars in our sky, suddenly dimmed by nearly 2/3 in 2019, sparking panic that it might be about to explode. Spoiler, it didn't, but the event left astronomers scrambling for answers. So why would a star as massive as Betelgeuse suddenly lose its shine? One leading suspect is cosmic dust. As these aging stars shed material, clouds of debris can form around them. If a particularly thick dust cloud drifts between the star and Earth, it could temporarily block our view, making the star appear to fade. Think of it like a cosmic lamp shade, only instead of soft lighting, you get a full-blown celestial mystery. But dust might not be the only culprit. Some scientists believe these dimming episodes could come from within the star itself. Supermassive stars like Betelgeuse have turbulent outer layers, where massive bubbles of hot gas rise and cool. If one of these cooler patches faces Earth, it could make the entire star look dimmer from our perspective. It's like a stellar version of a bad sunburn. One patch goes dark, and suddenly the whole star seems off. The weirdest part, some of these stars don't just dim, they do it on a schedule. Certain hypergiants pulse in and out like clockwork, as if something inside them is breathing. Could it be unstable fusion reactions, secret companion stars tugging at their atmospheres? Or something even stranger? For now, these flickering giants keep their secrets close. And just when you think you've got stars figured out, the universe throws another curveball, like the ones with magnetic fields so twisted they could rewrite the rules of physics. But that's a story for next time. Now, let's dive into something even more mind-bending: stars with magnetic fields so wild they could give a tornado a run for its money. Imagine a force so powerful it twists space itself, and you'll start to grasp the chaos unfolding around these cosmic giants. Take, for instance, a star called 845166. This monster doesn't just have a magnetic field, it has a magnetic nightmare, clocking in at tens of thousands of times stronger than Earth's. Its field isn't just intense, it's tangled, like a ball of yarn after a cat's had its way with it. Normally, a star's magnetic field lines are orderly, like the stripes on a barber pole. But here, they're knotted, looped, and snapping like cosmic whips, unleashing energy that could vaporize planets. So what causes this stellar insanity? One theory points to the star's insides. As supermassive stars churn, their plasma layers can spin at different speeds, creating a dynamo effect gone haywire. Picture stirring a pot of molten metal, except the pot is the size of a solar system, and the spoon is the force of gravity itself. The result: magnetic fields so twisted they defy every model astronomers have. And the fallout is just as bizarre. These chaotic fields don't just stay put, they reach out into space, warping the environment around the star. Charged particles get trapped in these magnetic knots, accelerated to near light speeds before being hurled into the cosmos like cosmic shrapnel. Nearby dust clouds ionized into glowing halos, planets stripped of their atmospheres in seconds. It's like the star has a temper tantrum and the entire neighborhood pays the price. The real kicker: some of these stars shouldn't even have magnetic fields this strong. By all rights, their sheer size and heat should smooth out the chaos. Yet here they are, breaking the rules and leaving scientists scrambling to rewrite the textbooks. And just when you think space can't get any weirder, wait until you hear about the stars that erupt without warning, flares so violent they could sterilize entire solar systems. But that's a story for another moment. Now, let's shift our gaze to something even more explosive: stars that seem calm one moment and unleash hellfire the next. These aren't your average solar flares. We're talking superflares, outbursts of energy so violent they make a supernova look tame by comparison. And the scariest part: they strike without warning. Take the star KIC 9852897. On the surface, it appeared stable, a quiet giant minding its own business. Then, in a fraction of a second, it released a flare packing the energy of 1 billion atomic bombs. For context, the most powerful solar flare ever recorded from our sun wouldn't even register as a spark next to this. These eruptions aren't just bright, they're planet killers. Any world orbiting too close would have its atmosphere blasted away, its surface scorched sterile in an instant. So why do these sleeping giants suddenly snap? One clue lies in their magnetic fields. Like a coiled spring, energy builds up in twisted magnetic loops near the star's surface. When the tension becomes too much, snap, the loops reconnect, catapulting charged particles and radiation into space at nearly light speed. But here's the puzzle: some of these stars show no signs of stress beforehand. No warning tremors, no flickering, just a cosmic detonation out of nowhere. The aftermath is just as chilling. Superflares don't just fry nearby planets, they rewrite the rules of habitability. Imagine a star like ours, gentle enough to nurture life, suddenly turning into a death ray. Astronomers have found evidence of such flares in young sun-like stars, suggesting even our solar system might have endured these blasts in its fiery youth. Could a superflare strike Earth today? Odds are low, but the universe has a way of keeping us humble. And if you think that's unsettling, wait until you hear about stars that don't just flare, they devour their cosmic neighbors whole. But that's a tale for another moment. Now, let's turn our attention to a cosmic horror story. Stars that don't just flare or flicker, but feast. Picture two stars locked in a gravitational dance, one a behemoth, the other its unwitting prey. This is binary star cannibalism, where a supermassive star literally devours its companion, growing monstrous in the process. Take the system VFTS 352 in the Tarantula Nebula. Here, a star 30 times the mass of our Sun orbits a smaller partner so closely that their atmospheres touch. Over time, the larger star siphons gas from its neighbor, swelling like a vampire after a meal. But this isn't just stellar theft, it's a transformation. The cannibal star spins faster as it gorges, its surface becoming so hot it blasts ultraviolet radiation powerful enough to ionize entire nebulas. Why does this happen? Gravity, of course, but with a twist. As the two stars age, the more massive one burns through its fuel faster, expanding into a bloated giant. Its outer layers grow unstable, and the smaller star trapped in a deadly embrace gets smothered. Matter spills from the victim to the predator, often forming a swirling disk of superheated plasma. Sometimes the feast ends in catastrophe. The stolen material triggers eruptions or even collapses the cannibal star into a black hole without a supernova. The aftermath is just as bizarre. Some of these stars become blue stragglers, appearing younger and hotter than they should be thanks to their stolen fuel. Others unleash kilonova's explosions that forge gold and platinum in their wake. And in rare cases, the victim fights back, spiraling inward until both stars merge in a cataclysm that shakes spacetime itself. But if you think that's unsettling, wait until you hear about stars that don't just consume, they vanish without a trace. That mystery, though, is a story for another moment. Now, let's shift our gaze to something even more elusive: ripples in the fabric of space-time itself. Around certain supermassive stars, astronomers have detected phantom shockwaves, mysterious disturbances that shouldn't exist. These aren't your typical stellar flares or solar winds. These are gravitational echoes, faint tremors that ripple outward like whispers from a hidden cosmic collapse. Take the star Vela X1, for example. Observations reveal strange, repeating pulses of energy around it, as if something massive, perhaps a failed supernova or a collapsing core, is sending out waves we can barely detect. The weirdest part, there's no visible explosion, no bright flash to explain it. It's like hearing thunder with no lightning. So what's causing these ghostly ripples? One theory points to failed supernovas, where a star's core implodes into a black hole so quickly that the outer layers vanish without a trace, leaving only these gravitational fingerprints behind. Another idea suggests these shockwaves come from dark matter interactions, invisible particles colliding with the star's core in ways we can't yet fully understand. But the implications are staggering. If these shockwaves are real, they could rewrite how we think about stellar deaths. Some might even be evidence of stars turning directly into black holes, skipping the supernova stage entirely. And here's the spine-tingling thought: what if these ripples are signs of something even stranger lurking in the cosmos, something we haven't even imagined yet? Just when you think space can't get any weirder, it throws another curveball. And speaking of cosmic surprises, wait until you hear about stars that spin so fast they nearly tear themselves apart. Now, let's turn our attention to stars that seem to be in a cosmic race against themselves, spinning so violently they flirt with self-destruction. These aren't just fast rotators, they're stellar speed demons whirling at velocities that defy logic. Take the star VFTS 102 in the Tarantula Nebula, for instance. It spins at a jaw-dropping 1 million miles per hour, so fast that its equator bulges outward, stretching the star into an unstable egg-like shape. At that speed, even a slight increase could rip it to shreds. But here's the real puzzle: what's cranking these stars up to such extreme speeds? One leading theory suggests they're cosmic thieves, stealing angular momentum from a nearby companion star or even a swirling disk of gas. Imagine a figure skater pulling their arms in to spin faster, but on a stellar scale. Another possibility involves mergers, two stars colliding and combining their spins into one dizzying frenzy. The consequences are just as wild. These rapid spinners can fling off massive amounts of material, creating glowing halos of ejected plasma. Some even generate intense magnetic fields, turning into cosmic powerhouses that blast radiation across space. And if they spin too fast, they might skip the usual supernova drama and collapse directly into a black hole, vanishing without a trace. What's truly mind-bending is how these stars challenge our understanding of physics. Their existence hints at gaps in our models, pushing scientists to rethink how stars evolve. Could there be even faster spinners lurking out there, ones we haven't spotted yet? Just when you think space has shown all its cards, it reveals another twist. And speaking of cosmic oddities, wait until you hear about stars that seem to wobble under the influence of invisible companions. Now let's unravel another cosmic mystery, stars that dance to an unseen rhythm. Picture a star swaying back and forth, not because it's unstable, but as if tugged by something invisible. Astronomers call this a wobble, and it's one of the clearest signs that a star isn't alone. But here's the twist: sometimes there's nothing visible orbiting it, no companion star, no planet, just empty space. So what's pulling on these stars? The leading suspects are black holes or clumps of dark matter. Take the star S2 near the Milky Way's center. It swings around an invisible object so massive that scientists are convinced it's a supermassive black hole. But other stars wobble in ways that don't quite fit the black hole explanation. Some might be orbited by smaller, hidden black holes, stellar remnants so dense they swallow light itself. Others could be feeling the gravitational whisper of dark matter, that mysterious substance making up most of the universe's mass yet refusing to interact with light. Then there's the eerie case of stars that wobble unpredictably, as if their unseen companions are moving in erratic patterns. Could these be primordial black holes left over from the early universe? Or pockets of dark matter behaving in ways we don't yet understand? Every wobble is a clue, and each one pushes us closer to answering one of astronomy's biggest questions: what exactly is lurking in the shadows of space? And just when you think it can't get stranger, some stars don't just wobble, they flicker, as if their invisible partners are playing tricks on the light we see. But that's a puzzle for another moment. For now, let's turn to stars that can't seem to decide how hot or cold they want to be. Now, let's shift our gaze to stars that can't seem to make up their minds, cosmic giants that swing between scorching heat and chilling coolness like a malfunctioning thermostat. Imagine a star that's burning fiercely one moment, then dimming to a cooler glow the next, with no obvious reason. Astronomers call these erratic shifts temperature swings, and they're more than just stellar mood swings. They're clues to something deeply mysterious happening beneath the surface. Take the famous hypergiant star Vy Canis Majoris. Normally, it's a blazing inferno, but over the past century, it's undergone dramatic cooling episodes, dimming by as much as 60% for years at a time. Then, just as suddenly, it roars back to full intensity. What's going on? One theory points to colossal convection currents. Think of a boiling pot, but on a scale where bubbles of plasma the size of solar systems rise and collapse, temporarily shielding the star's heat. Another idea suggests titanic eruptions, where the star hurls massive clouds of dust into space, creating a temporary sunshade that cools its visible light. But here's where it gets even weirder. Some stars don't just cool down, they spike in temperature unexpectedly, as if someone turned up a hidden dial. In 2016, the star Betelgeuse, already a variable star, suddenly brightened by almost 50% in just a few months, leaving scientists scrambling for explanations. Was it a massive magnetic flare, a collision with an unseen object, or something entirely new? The most puzzling cases are stars that flip between hot and cool phases in irregular, unpredictable patterns, defying all known models of stellar behavior. Could these swings hint at unstable fusion processes in their cores? Or are we seeing the fingerprints of exotic physics, like quantum fluctuations playing out on a stellar scale? Every erratic pulse challenges our understanding of how stars live and evolve. And just when you think you've seen it all, some stars add another twist. Their temperature swings coincide with bizarre changes in their magnetic fields or chemical composition, as if the entire star is rewriting its own rules. But that's a story for another day. For now, let's turn our attention to stars that pulse with a rhythm so precise, it's like listening to the heartbeat of the cosmos itself. Now, let's tune into the cosmos and listen to its rhythm. Stars that pulse with the steady, hypnotic beat of a celestial metronome. These aren't random flickers or chaotic outbursts, but precise, rhythmic pulses of light, as if the stars themselves are breathing. Astronomers call this phenomenon cosmic heartbeats, and few stars embody it more dramatically than Eta Carinae, a hypergiant so volatile it could explode any century now. Picture this: every 5.5 years, like clockwork, Eta Carinae's brightness surges, then fades, then surges again. It's not just a subtle flicker. This star's pulse can outshine entire galaxies at its peak. What's driving this cosmic heartbeat? The leading theory involves a dance of doom between Eta Carinae and a smaller, hidden companion star. As they orbit each other, the hypergiant's fierce winds collide with the companions, creating shockwaves that heat up and glow brighter, then cool as the stars swing apart. It's a lethal tango, pumping light into space with eerie regularity. But Eta Carinae isn't alone. Other supermassive stars, like RS puppies, pulse with similar precision, their light echoing off surrounding dust clouds like a lighthouse beam through fog. These rhythms aren't just beautiful, they're cosmic yardsticks. By measuring the timing of these pulses, astronomers can calculate distances across the universe with stunning accuracy. Yet some heartbeats defy explanation. Take the star HD 89087, which pulses not just in brightness but in temperature and size, swelling and shrinking like a living thing. Could these rhythms reveal unstable fusion reactions in the core? Or are they the death throes of a star on the brink of collapse? Every steady pulse is a clue, and a reminder that even in the chaos of space, there's music in the madness. And just when you think you've decoded the pattern, the universe throws a curveball. Some stars skip beats or accelerate their pulses as if racing toward an invisible finish line. What's speeding them up? Is it internal turmoil or the gravitational pull of a hidden neighbor? The answers might rewrite our understanding of stellar life cycles. But for now, let's turn our attention to another enigma. Stars shrouded in ghostly halos of gamma rays, as if they're whispering secrets in a language of light we're only beginning to understand. Now, let's step into the eerie glow of another cosmic mystery, stars wrapped in ghostly halos of gamma rays, as if they're cloaked in an otherworldly aura. These faint, shimmering rings of high-energy light aren't just beautiful, they're cosmic puzzles that might rewrite the rules of stellar physics. Take the star LS 539, for example. It's not just burning brightly in visible light, it's surrounded by a barely detectable gamma-ray glow, like a faint whisper in a room full of noise. What's causing this eerie emission? One leading theory points to antimatter, the elusive counterpart to ordinary matter. When antimatter particles meet their matter twins, they annihilate in a flash of gamma rays. Could these stars be producing and somehow trapping antimatter in their turbulent outer layers? It's a tantalizing possibility, but the truth might be even stranger. Some researchers suggest these halos are the aftermath of violent stellar winds slamming into rogue clouds of interstellar gas, sparking particle collisions intense enough to generate gamma rays. Others speculate about hidden neutron stars or black holes lurking nearby, their gravitational pull twisting magnetic fields into gamma-ray factories. But here's the real twist: these halos aren't static. They flicker and shift over time, as if the stars themselves are playing a cosmic game of hide and seek. One moment the glow is steady, the next it flares unpredictably. Is this the signature of unstable magnetic fields, or could it hint at something even more exotic, like quantum effects playing out on a stellar scale? And then there's the odd case of Gamma Velorum, a star whose gamma-ray halo pulses in sync with its rotation, like a lighthouse beam cutting through fog. Why would gamma rays, the highest energy light in the universe, dance to the rhythm of a spinning star? The answer might lie in the star's chaotic magnetic environment, where particles are whipped to near light speeds, then slammed together in bursts of radiation. Yet for all their mystery, these halos aren't just celestial curiosities. They're cosmic laboratories offering clues about how matter and energy behave under extreme conditions we can't recreate on Earth. Every flicker, every shift in these ghostly glows could be a piece of a puzzle we're only beginning to assemble. And just when you think you've glimpsed the answer, the universe throws another curveball. Some of these gamma-ray halos stretch far beyond their host stars, as if the stars are trailing invisible comet tails of high-energy light. What's carrying this energy so far into space? The hunt for answers is far from over, but one thing's certain: in the shadow of these glowing enigmas, the universe feels stranger than we ever imagined. Now, let's turn to an even more baffling act in the stellar circus: stars that vanish without a trace, as if space itself has swallowed them whole. But the cosmic stage isn't done surprising us yet. Imagine a star massive, luminous, burning bright for millions of years, suddenly winking out of existence like a candle snuffed by an unseen hand. No explosion, no debris, just gone. This isn't science fiction. It's the baffling reality of stars that vanish without a trace, defying everything we know about stellar deaths. Take the case of N6942, a blue supergiant 25 times heavier than our Sun. Astronomers watched it for years, tracking its brilliant glow, until one day it simply wasn't there. No supernova, no fading embers, just an empty patch of sky where a star once blazed. How does something so massive disappear without a cosmic farewell? One theory suggests these stars might collapse directly into black holes, skipping the supernova stage entirely. Normally, when a massive star dies, its core implodes, triggering a shockwave that rips the outer layers apart in a spectacular explosion. But if the core is too heavy or unstable, the star might implode so violently that nothing escapes, not even light. It's like a trapdoor opening beneath the star, swallowing it whole into a black hole's infinite darkness. Then there's the eerie possibility of failed supernovas. Some stars might expel just enough material to dim dramatically, then quietly shrink into obscurity. Others could be cloaked by thick dust clouds, hiding their final moments from our telescopes. But even these explanations don't fully account for stars like Kinman's dwarf, a luminous variable star that vanished from sight, leaving behind no detectable remnant. The most unsettling idea: some of these stars might not be dying at all. Could they be ejected from their galaxies by gravitational slingshots, hurled into the void where they fade from view? Or more bizarrely, might they be encased in exotic matter, rendering them invisible to our instruments? Whatever the truth, these vanishing acts force us to rethink stellar life cycles. If stars can disappear without warning, how many others have we missed? And what does that mean for our understanding of the universe's most violent events? The mystery lingers like a shadow in the cosmos, a reminder that even the brightest giants can slip away unnoticed. Now, let's shift our gaze to another stellar marvel: stars that defy the laws of chemistry, forging rare elements in their cores like cosmic alchemists. Now, let's turn our attention to one of the universe's most astonishing workshops: stars that act like cosmic alchemists, crafting elements so rare they defy the rules we thought governed stellar chemistry. Deep inside certain supermassive stars, conditions become extreme enough to forge elements like gold, platinum, and uranium, materials so heavy they shouldn't form easily in nature. Conventional models suggest these metals are born only in the violent chaos of colliding neutron stars or supernova explosions. But some stars seem to skip the middleman, cooking up these exotic elements right in their cores like a celestial factory. Take the red giant star Przybylski's star, for example. Its atmosphere is laced with bizarre elements like promethium and einsteinium substances so unstable they typically vanish within years under earthly conditions. Yet here they are, lingering in a star's outer layers. How? One theory points to intense magnetic fields twisting the star's interior, creating pockets where nuclear reactions run wild, fusing atoms into forms never seen elsewhere. Then there's the R process, short for rapid neutron capture, a frenzied chain reaction where atomic nuclei bombard neutrons at breakneck speed, building heavier and heavier elements. While neutron star mergers were thought to be the primary R process sites, certain supermassive stars exhibit traces of these elements in their spectra, hinting they might host their own hidden neutron-rich environments. Imagine a star's core so dense, so turbulent, it mimics the extreme physics of a neutron-star collision. But the real head-scratcher, some of these element factories shouldn't exist at all. Stars massive enough to produce heavy metals usually tear themselves apart long before they can enrich the cosmos. Yet spectroscopic data reveals their fingerprints in ancient star clusters, suggesting they not only survived but spread their metallic creations across galaxies. What does this mean for us? Every gold ring, every platinum catalyst, even the uranium-fueling nuclear reactors, they might owe their existence to stars that bent the rules of physics. And if these stellar forges are more common than we thought, it could rewrite the story of how the universe builds the ingredients for planets, life, and even technology. The cosmos has always been the ultimate chemist, but these stars, they're the renegades of the periodic table, crafting elements where none should be. And as we'll see next, their defiance doesn't stop there. Now, let's shift our gaze to something even more baffling: stars that seem to laugh in the face of gravity itself. Picture this: vast loops of superheated plasma, stretching thousands of miles into space, twisting into shapes that defy every rule we know about magnetic fields. These aren't just cosmic accidents, they're full-blown rebellions against physics. Take the star known as HR 9024, for example. Observations revealed gigantic plasma arcs soaring from its surface, curving back in ways that shouldn't be possible. Normally, a star's magnetic field keeps its plasma in check, like invisible reins guiding a wild horse. But here, the plasma behaves as if those reins don't exist, forming loops that spiral, knot, and even snap back violently. Scientists call these open field lines, where the magnetic grip weakens, letting plasma escape in chaotic bursts. What's even stranger, some of these loops don't just bend, they break entirely. In certain supermassive stars, plasma gets hurled so far out that it should dissipate into space. Instead, it lingers, forming glowing halos or even reconnecting with the star in ways that mimic cosmic slingshots. One theory suggests hidden magnetic instabilities, like kinks in a hose, create pressure points that warp the plasma's path. Another idea points to external forces, perhaps the tug of an unseen companion star or even dark matter, disrupting the star's magnetic balance. But the real mystery, these loops might be more than just stellar oddities. Some researchers think they could explain why certain stars lose mass at unpredictable rates, shedding material far faster than models predict. Others wonder if these gravity-defying arcs are behind bizarre X-ray flares, where trapped plasma suddenly releases energy equivalent to millions of atomic bombs. Imagine a star so powerful, so unruly, it sculpts its own fiery artwork in the void, art that challenges everything we thought we knew about cosmic order. And as we'll soon see, the universe has even more surprises in store. Now, let's step into a cosmic time machine, where the past isn't just remembered but literally lights up the present. Imagine a star that died centuries ago. its final explosion long faded from view, only for its ghostly afterglow to suddenly reappear in the night sky. These aren't holograms or illusions, they're light echoes, one of the universe's most hauntingly beautiful tricks. Take the case of Eta Carinii, a star that erupted in the 1840s in a cataclysmic event called the Great Eruption. For years, astronomers watched as its light faded until, over a century later, faint ripples of that same explosion began glowing again. Here's how it works. When a star explodes, light races outward in all directions. But some of that light hits interstellar dust clouds, bouncing off like a flashlight in a foggy room. The dust acts as a cosmic mirror, reflecting the explosion's light back to us, but with a delay. By the time these echoes reach Earth, the original star might already be a black hole or neutron star. What's wild is that these echoes aren't just delayed replays, they're scientific gold mines. By studying them, astronomers can re-examine ancient stellar explosions with modern telescopes, like rewatching a historic event in high definition. For example, light echoes from Tycho's supernova, a star that died in 1572, reveal details about the explosion's chemistry that 16th century observers couldn't possibly have seen. Some echoes even show changes in the original explosion's light, hinting at turbulent processes during the star's death throes. But the real mystery: some echoes don't match any known supernova in human records. In 2002, a faint echo lit up near the constellation Cassiopeia, tracing back to an undocumented star death around the late 1600s. Was it missed because of cloudy skies, or because it belonged to a rare, quiet type of supernova that leaves no visible trace? Either way, these flickers from the grave remind us the universe's history isn't written in stone, it's written in light, waiting to be read. And speaking of cosmic secrets, our next stop takes us to stars that literally shake the fabric of space now. Let's turn our attention to something that might sound like science fiction, but is very real: starquakes. Picture this: a star millions of times larger than our sun, shuddering with seismic waves so powerful they could rip planets apart. These aren't just gentle tremors, they're cosmic earthquakes on a scale we can barely fathom. Take a star like SGR 1806-20, a magnetar with a magnetic field so intense it could strip the data from your credit card from halfway across the galaxy. In 2004, this star unleashed a starquake so violent it released more energy in 1/10 of a second than our sun emits in 150,000 years. That's the equivalent of billions of atomic bombs detonating at once. So how do these starquakes happen? On Earth, earthquakes occur when tectonic plates shift. But on a star, especially a magnetar, it's the crust, a dense, rigid layer of iron and exotic particles that cracks under unimaginable stress. The star's insane magnetic field twists and strains this crust until it snaps, sending shockwaves rippling across the surface. These waves can even distort space-time itself, creating gravitational waves detectable across the universe. What's even wilder, some starquakes don't just shake the star, they rewrite its magnetic field. In 2007, a starquake on another magnetar, SGR 1900+14, actually altered its magnetic poles like a cosmic compass suddenly flipping directions. Scientists are still trying to figure out how these quakes can reshape a star's very essence. And here's the kicker: starquakes might be the universe's way of letting us peek inside these cosmic giants. Just like seismologists use earthquakes to study Earth's interior, astronomers analyze starquakes to map the hidden layers of these colossal objects. Every tremor sends back data, revealing secrets about the star's density, composition, and even the bizarre states of matter lurking in its core. But the mystery doesn't end there. Some starquakes seem to come out of nowhere with no clear trigger. Are they caused by internal collapses, magnetic snapbacks, or something even stranger? One thing's for sure: when a star shakes, the universe listens. And speaking of listening, our next stop takes us to stars that don't just shake, they sing. Now imagine a cosmic fire hose blasting matter into space at nearly the speed of light, only to suddenly twist and bend like it's got a mind of its own. That's the bizarre reality of polar jets, the high-speed streams of plasma that erupt from the poles of supermassive stars. Normally, these jets shoot straight out like perfectly aimed laser beams. But sometimes they go rogue. Take the star system SS433, for example. Its jets should be arrow straight, but instead they spiral wildly as if caught in an invisible cosmic whirlpool. Astronomers call this precession, where the jets wobble like a spinning top running out of steam. But here's the twist: some jets don't just wobble, they curve. In 2018, scientists spotted a jet from a star called X3 that bent at a 45-degree angle mid-flight, defying every model of stellar physics. The leading theory, a hidden black hole or dense companion star, might be yanking the jet off course with its gravity, like a puppeteer pulling strings. Then there's speed. These jets aren't just fast, they're relativistic, meaning they approach light speed. The energy required to launch matter that fast is mind-boggling. Picture a star's magnetic field acting like a particle accelerator, twisting and snapping until it flings plasma into space with the force of 1 billion nuclear explosions. But even then, nature finds ways to surprise us. Some jets, like those from the star Vela X1, pulse unpredictably, surging and fading as if the star itself is gasping for breath. And the consequences: when these jets veer off course, they can sterilize entire star systems. A single misdirected jet could strip planets of atmospheres or bathe them in deadly radiation. Yet, paradoxically, they might also seed galaxies with heavy elements, scattering the ingredients for new stars and even life. So why do some jets stay true while others spiral into chaos? Is it hidden companions, unstable magnetic fields, or something even weirder? One thing's certain: when polar jets go wild, they rewrite the rules of the cosmos. Up next, we'll unravel the mystery of stars that almost die but don't now. Let's turn our attention to one of the most baffling cosmic illusions: stars that stage a dramatic supernova performance, only to stick around afterward like nothing happened. These so-called phantom supernovas defy everything we know about stellar deaths. Normally, when a massive star explodes, it's game over, a brilliant, violent finale. But some stars, they fake their own demise. Take the case of SN 2014c, a star that flared up with the intensity of a supernova, dazzling telescopes worldwide. Astronomers braced for the star's collapse into a black hole or neutron star, but it never came. Instead, the star dimmed and carried on, as if it had just coughed out a cosmic smokescreen. Theories range from a failed supernova, where the star's core collapses inward without a full explosion, to a massive eruption of gas that mimics a supernova's glow. Then there's Eta Carinii, a ticking time bomb of a star that's been teasing astronomers for centuries. In the 1840s, it unleashed a colossal outburst, briefly becoming the second brightest star in the sky. For decades, scientists assumed it was a supernova in slow motion. Yet, Eta Carinii stubbornly refuses to die, its eruptions more like temper tantrums than a final bow. Some speculate it's hoarding energy for an even bigger explosion, while others wonder if it's rewriting the rules of stellar mortality. What's truly unsettling is how these phantom events mess with our cosmic senses. If stars can fake their deaths, how many supernovas we've recorded were just elaborate tricks? And what does it mean for the fate of the universe's heaviest stars? One theory suggests these stars might be quietly collapsing into black holes without the usual fireworks, leaving behind only a gravitational whisper. So why do some stars cheat death? Is it a quirk of their internal physics, or are we missing a fundamental piece of the stellar life cycle? Whatever the answer, phantom supernovas remind us that the universe loves a good plot twist. Coming up, we'll dive into the eerie phenomenon of cosmic vampirism, stars that steal life from their neighbors to stay young. Now, imagine a cosmic thief lurking in the darkness of space, not a black hole or a rogue planet, but a star that survives by stealing life from its neighbors. This is cosmic vampirism, where massive stars drain the atmosphere of nearby companions to cheat time and stay unnaturally young. Take the case of a binary star system where one star grows old and puffs up, while its hungry partner, often a white dwarf or neutron star, siphons off its outer layers. Like a vampire feasting on its prey, the thief star grows brighter and hotter, rejuvenated by stolen gas. Some even explode prematurely, their stolen fuel triggering violent outbursts. But the most extreme cases involve blue straggler stars that glow younger and bluer than they should. In crowded star clusters, these stars are almost always guilty of cosmic theft, either by stripping a partner or colliding with another star to merge their lifespans. It's as if they found a fountain of youth in the chaos of space. What's eerie is how this theft distorts our understanding of stellar evolution. If stars can reset their clocks by stealing, how do we calculate their true ages? And could this explain why some star clusters have oddly youthful members amidst ancient stars? The universe, it seems, has no rules against celestial larceny. Up next, we'll explore an even darker mystery: stars whose strange motions hint at collisions with the invisible grip of dark matter. Now, let's step into the shadows of the cosmos, where some stars move as if tugged by unseen hands. These stars don't follow the usual rules of gravity. Their paths twist and wobble in ways that can't be explained by the visible matter around them, the culprit. Dark matter, the universe's most elusive ghost. Take a star like one in the Draco Dwarf galaxy. It orbits the Milky Way at speeds that defy logic, as if something invisible, something massive, is pulling it off course. Astronomers call this the missing mass problem. The star's motion suggests it's brushing against dark matter, an invisible substance that makes up over 80% of the universe's matter but refuses to interact with light. Here's where it gets stranger. Some supermassive stars flicker or accelerate abruptly, as if plowing through dense patches of dark matter. Imagine a ship sailing through unseen waves. These stars might be feeling the drag of dark matter clumps, their gravity subtly altering the star's behavior. The wildest theory: dark matter could even collect inside stars like a shadowy core. If true, this might explain why some stars burn hotter or live longer than expected. It's as if dark matter is secretly fueling them, a cosmic cheat code written in the stars themselves. But the biggest question remains: if dark matter is everywhere, why do only some stars show these odd motions? Could they be tracers, revealing the hidden architecture of the universe? Up next, we'll unravel another cosmic illusion: stars that bend time itself, making light from the past arrive late to the party. Now, let's turn our attention to one of the most mind-bending tricks of supermassive stars: their ability to manipulate time itself. Picture this: a star so massive that its gravity doesn't just pull on nearby objects, it warps the very fabric of space-time around it. This cosmic distortion acts like a lens, bending light that passes close to the star and creating what astronomers call time-delayed light. Here's how it works. When light from a distant object, like a galaxy or another star, travels toward us, it might pass near one of these supermassive stars. The star's immense gravity curves the light's path, forcing it to take a longer route to reach our telescopes. The result: we see multiple images of the same object, some arriving later than others, as if the star is replaying scenes from the past. Take the famous example of a distant quasar lensed by a foreground galaxy. The quasar's light splits into multiple images, each arriving at different times, sometimes years apart. It's like watching a cosmic echo where the same event plays out again and again, just slightly out of sync. But supermassive stars take this phenomenon to the extreme. Their intense gravity can stretch delays to days or even weeks, creating ghostly afterimages of stellar explosions or flares that technically happened long ago. Imagine seeing a supernova flash, then seeing it flash again months later, as if the universe hit rewind. Why does this matter? These time delays aren't just cosmic quirks, they're tools. By studying them, astronomers can map the invisible mass around these stars, including dark matter, and even test Einstein's theory of relativity in extreme environments. Next up, we'll dive into another stellar mystery, storms so fierce they can strip planets bare. Now, let's shift gears to another jaw-dropping spectacle: supermassive stars unleashing solar winds so violent they can rip planets apart. Imagine a star not just shining but screaming its energy into space, hurling storms of charged particles at nearly the speed of light. These aren't your average solar breezes, they're cosmic hurricanes, capable of scouring entire worlds down to their bare cores. Take the infamous case of HD 189733b, a gas giant orbiting too close to its host star. Astronomers watched in awe as its atmosphere, once thick with swirling gases, was torn away in colossal plumes, like sand blasting a planet into oblivion. The culprit, a supermassive star's relentless solar wind, bombarding the planet with enough energy to vaporize thousands of Earth atmospheres every second. But here's the twist: these winds aren't just powerful, they're erratic. Unlike our sun's steady stream, supermassive stars spit out particle storms in chaotic bursts, some 100 times stronger than anything our solar system has ever seen. One day, a nearby planet might bask in relative calm, the next, it's caught in a particle tsunami, its skies literally being blown into space. Why does this chaos matter? It reshapes the very idea of habitable zones. Even planets at a safe distance could have their atmospheres shredded over time, turning potential paradises into airless wastelands. Some scientists even think these winds might explain why we found so many bare, rocky worlds former Earth stripped down to their bones by stellar tempests. Up next, we'll explore an even stranger twist: stars where the rules of quantum physics rewrite the script right in their atmospheres. Now, let's venture into the bizarre realm where the tiny world of quantum physics collides with the colossal scale of supermassive stars. Imagine an atmosphere so dense and extreme that the usual rules of physics start to bend, where particles behave in ways that defy common sense, flickering in and out of existence or tunneling through barriers like ghosts. This isn't science fiction, it's the reality for some supermassive stars, where quantum effects take center stage in their outer layers. Take the case of a star's atmosphere so packed with energy that electrons, instead of orbiting neatly, begin to act like waves smearing across space in a quantum haze. Under these extreme conditions, particles can suddenly vanish from one spot and reappear in another, a phenomenon called quantum tunneling. Normally, this happens on microscopic scales, but in these stellar giants, it can influence how heat moves through their atmospheres, creating bizarre temperature fluctuations that baffle astronomers. Even stranger, some supermassive stars may host a quantum soup where matter and antimatter particles spontaneously form and annihilate, releasing bursts of energy that warp the star's outer layers. Picture a cosmic dance where particles blink in and out of existence, subtly altering the star's light and even its stability. Why does this matter? Because these quantum quirks could explain why some supermassive stars shine brighter or dimmer than predicted, or why their atmospheres sometimes behave like they're caught in an invisible tug of war. It's a reminder that even in the vastness of space, the tiniest particles can have the biggest surprises. Next up, we'll tune into the mysterious hum resonating from deep within certain stars, a cosmic vibration that might hold clues to their hidden secrets. Now, let's listen to the universe's hidden soundtrack, a deep, resonant hum echoing from the hearts of certain supermassive stars. These aren't random noises but precise, low-frequency vibrations, like the steady thrum of a cosmic bass line. Astronomers first picked up these eerie signals using sensitive space telescopes, and what they found was anything but ordinary. Imagine a star pulsating like a colossal bell, its entire structure vibrating in slow, rhythmic waves. These hums are caused by turbulent movements deep within the star's core, where unimaginable pressures and temperatures create seismic ripples that travel outward. Unlike the chaotic flares or bursts we've seen in other stars, these vibrations are oddly consistent, some maintaining the same frequency for years. One leading theory suggests these hums could be tied to the star's magnetic fields twisting and snapping like rubber bands, releasing energy in the form of these deep tones. Another idea points to internal gravity waves, where dense material sinks and lighter plasma rises, creating a slow-motion churn that resonates through the star. But here's the real mystery. Some of these humming stars shouldn't be stable enough to produce such clean frequencies. Their cores are so violent that any vibrations should get scrambled, yet the signals remain crystal clear. It's as if something or someone is tuning these stars like instruments in a galactic orchestra. What's at stake? Decoding these hums could reveal secrets about a star's inner structure, helping us predict its lifespan or even spot hidden companions like black holes lurking nearby. Up next, we'll explore stars that blur the line between reality and illusion, stellar giants that mimic black holes in ways that defy logic. Now, let's step into the realm of cosmic illusions, where some supermassive stars pull off the ultimate trick, behaving like black holes. These stellar giants don't just bend light, they toy with it, creating moments where even photons seem to vanish. Imagine a star so dense and massive that its gravity warps space-time just enough to trap light temporarily, like a cosmic magician's sleight of hand. Scientists first noticed this eerie phenomenon when certain stars flickered in ways that defied explanation. Normally, light escapes a star's surface effortlessly, but in these cases it stutters delayed or even dimmed as if struggling to break free. The culprit, a gravitational grip so intense that it mimics a black hole's event horizon, the point of no return. While these stars aren't actual black holes, their extreme mass and compact size create a similar effect on nearby light. One standout example is a class of hypergiants with cores so compressed that their outer layers teeter on the edge of collapse. As material spirals inward, it accelerates to near-light speeds, generating forces that twist space-time. For brief moments, light passing too close gets caught in this whirlpool, creating the illusion of disappearance. Some theories suggest magnetic fields play a role, corralling plasma into dense knots that amplify the star's gravitational pull. But here's what baffles researchers. Unlike black holes, these stars eventually release the trapped light. It's as if the universe hit pause, then resumed playback. This behavior challenges our understanding of how matter and energy interact under extreme conditions. Could these stars be cosmic experiments testing the limits of physics, or are they hiding clues about the mysterious transition from star to black hole? Up next, we'll unravel an even stranger cosmic thread: stars separated by vast distances that pulse in perfect sync, as if controlled by an invisible conductor. Now, let's turn our attention to one of the most baffling symphonies in the cosmos: stars separated by thousands of light years, pulsing in flawless harmony. Picture two colossal stars, each a titan in its own galaxy. Yet somehow their brightness rises and falls in perfect lockstep, as if choreographed by an unseen hand. This phenomenon, known as cosmic synchronization, defies everything we know about stellar behavior. Normally, stars pulse due to internal processes, fusion reactions, seismic waves, or magnetic upheavals, all independent of one another. But in these rare cases, the rhythm is too precise to be coincidence. One leading theory suggests hidden gravitational bridges, filaments of dark matter or spacetime itself, might link these stars like invisible puppet strings. Another idea points to resonant frequencies. Perhaps these stars vibrate at the same natural pitch, like tuning forks responding to the same silent note. Take, for example, a pair of hypergiants observed in the Andromeda and Triangulum galaxies. Despite being separated by over 2 million light-years, their light curves match down to the minute. Even stranger, when one star's pulse shifts slightly, the other adjusts within days, as if exchanging signals faster than light should allow. Some researchers speculate quantum entanglement could play a role, though that's a stretch for objects so massive. Others wonder if we're seeing echoes of a shared origin, a long-vanished stellar nursery that imprinted identical rhythms on its offspring. What's clear is this: cosmic synchronization hints at forces or connections we've yet to understand. Could it be a clue to deeper layers of the universe's structure, or just a fleeting alignment in the chaos of space? Next, we'll dive into another stellar spectacle: monstrous waves of plasma, taller than continents, crashing across the surfaces of these celestial giants. Now, imagine a star so colossal that its surface churns with waves taller than entire continents, monstrous tsunamis of superheated plasma, crashing in slow motion across a cosmic shore. These aren't the gentle ripples of our sun's surface. These are titanic surges born from turbulence deep within the star's core, where pressures and temperatures defy imagination. Picture this: a hypergiant star, its outer layers a seething ocean of plasma. Suddenly, a disturbance, perhaps a starquake or a magnetic snap, sends a shockwave racing outward. Within hours, a wall of plasma, hundreds of thousands of miles high, begins to roll across the star's surface. The energy behind these waves is staggering. A single plasma tsunami can release more energy than our sun emits in a century, yet on these stellar behemoths, it's just another day in their chaotic lives. What's truly bizarre is how these waves behave. Unlike water waves, which dissipate quickly, plasma tsunamis can travel for weeks, even months, before fading. Some get trapped in magnetic loops, sloshing back and forth like liquid in a tilted bowl. Others collide, merging into even larger waves that warp the star's light, making it flicker like a candle in the wind. Take Eta Carinae, for example. Observations revealed a plasma wave so vast it temporarily dimmed the star's brightness, as if something had draped a veil across its face. Scientists suspect these tsunamis might even hurl material into space, seeding the cosmos with heavy elements. So what triggers these epic waves? Theories range from internal explosions, mini supernovas inside the star, to gravitational tugs from hidden companions. One thing's certain: plasma tsunamis remind us that even the surfaces of stars are anything but calm. Next up, we'll encounter stars that refuse to die, stellar zombies that cheat death in the most puzzling ways. But just when you think you've seen it all, the cosmos throws another curveball: stars that simply refuse to die. Meet stellar zombies, the ultimate survivors of the universe. These aren't your average stars fading quietly into the night. No, they cheat death over and over, baffling astronomers with their stubborn defiance. Take the case of supernova imposters. Some massive stars flare up dramatically, brightening to near supernova levels enough to make scientists think they're witnessing a star's final act. But then, against all odds, the star settles back down, as if it just shrugged off a cosmic near-death experience. How? One theory suggests these stars might eject just enough material to relieve internal pressure, staving off total collapse. It's like a pressure valve on a boiling kettle, releasing steam before disaster strikes. Then there's the even stranger phenomenon of failed supernovas. Some stars, instead of exploding in a blaze of glory, simply vanish, poof, gone. Telescopes catch their light fading, but there's no explosion, no remnant, no trace. Did they collapse directly into black holes without a sound? Or did they somehow shed their outer layers so stealthily that we missed it? Either way, these stars rewrite the rules of stellar death. And let's not forget the real overachievers, stars like Eta Carinae, which has endured multiple violent eruptions over centuries, losing enough material to form several suns, yet still clinging to existence. It's a cosmic game of brinkmanship, teetering on the edge of destruction but never quite toppling over. What keeps these stellar zombies ticking? Some might have dense cores that stabilize them, while others could be locked in gravitational dances with unseen companions, siphoning off energy to stay alive. One thing's clear, their refusal to die forces us to rethink how stars live and how they end. Coming up next, we'll unravel a paradox that defies logic: stars caught between two states of existence, as if the universe itself can't make up its mind. Now, let's step into one of the most baffling corners of stellar behavior: stars that defy the very laws of existence. Imagine a cosmic coin flip, but instead of landing on heads or tails, it somehow lands on both at the same time. That's the essence of the duality paradox, where supermassive stars appear to exist in two contradictory states simultaneously, leaving astronomers scratching their heads. Take the case of certain hypergiants observed flickering between two distinct brightness levels, as if they can't decide whether to be luminous giants or dimmer, cooler stars. Telescopes capture these stars emitting light signatures that match two entirely different stellar phases, like a celestial chameleon switching colors faster than physics should allow. One leading theory suggests these stars might be trapped in a gravitational tug of war, with their outer layers oscillating between expansion and contraction. Picture a balloon inflating and deflating rapidly, but on a scale so vast it warps our understanding of stellar stability. Then there's the eerie phenomenon of spectral duality, where a single star's light reveals the chemical fingerprints of two opposing environments, one scorchingly hot, the other surprisingly cool. It's as if the star's atmosphere is split into conflicting personalities, with no clear boundary between them. Could this be the work of massive magnetic fields twisting the star's outer layers into chaotic knots? Or is it evidence of some deeper, undiscovered physics at play? Even more puzzling are stars that seem to occupy 2 points in space at once. Observations have caught rare cases where a star's position appears to shift slightly, as if it's in 2 places simultaneously, a trick that even Einstein's relativity struggles to explain. Some scientists speculate these could be light echoes from past eruptions, creating ghostly duplicates in the data. Others wonder if we're glimpsing a hidden companion, like a black hole or neutron star, warping space-time around its host. What makes these duality paradoxes so thrilling is how they challenge our bedrock assumptions about reality. In a universe where stars can be 2 things at once, the line between the possible and the impossible blurs. And just when we think we've got it figured out, the cosmos reminds us there's always another layer to unravel. Up next, we'll confront a mystery that ties all these strange behaviors together, asking the ultimate question: could supermassive stars be the universe's way of filtering out life before it even begins? Now, let's zoom out to the bigger picture, where the strangest behaviors of supermassive stars might hold the answer to one of the universe's greatest mysteries. The Fermi paradox asks a haunting question: if the cosmos is so vast and ancient, why haven't we found any signs of intelligent life beyond Earth? One chilling possibility is that supermassive stars act as a cosmic filter, wiping out civilizations before they ever get the chance to flourish. Think about it, these stars are capable of unleashing unimaginable destruction: superflares that sterilize entire solar systems, gamma-ray bursts that fry planets light years away, or sudden collapses into black holes without warning. If a civilization happens to evolve near one of these unstable giants, its fate could be sealed long before it develops the technology to escape. The universe might be littered with the ruins of worlds that never stood a chance. Even more unsettling is the idea that some of these stellar behaviors could be entirely invisible to us until it's too late. A star might seem stable for millennia, only to erupt without any detectable precursor. Or it could vanish into a black hole, dragging nearby planets into oblivion before anyone realizes what's happening. If this is the norm across the cosmos, it would explain why space feels so empty. Life might constantly be reset by these celestial time bombs. But here's the twist: what if supermassive stars aren't just destroyers but also creators? Their violent deaths seed galaxies with the heavy elements needed for planets and life to form. In this way, they could be both the architects and executioners of cosmic civilizations. It's a grim balance, but one that might explain why we're here to ponder it at all. So as we look up at the night sky, we're left with a humbling thought. The very stars that light our way could also be the universe's ultimate test, a filter that only the luckiest or most resilient survive. And that makes our existence feel all the more extraordinary. With that, we've reached the end of our journey through the 30 strangest behaviors of supermassive stars. From runaway hypergiants to cosmic heartbeats, each mystery reminds us how much we still have to learn. Which of these celestial oddities fascinated you the most? Let us know in the comments below, and don't forget to like, subscribe, and hit the notification bell so you never miss an exploration into the wonders of space. Until next time, keep looking up. As we wrap up this cosmic journey, let's take a moment to reflect on the sheer strangeness of supermassive stars. From hypergiants racing across galaxies to stars that vanish without a trace, each of these 30 behaviors shatters our expectations of how the universe should work. They're not just oddities, they're cosmic puzzles forcing us to rethink the laws of physics, the life cycles of stars, and even the fate of potential civilizations. What makes these mysteries so thrilling is how much they reveal about our own place in the cosmos. Every time we solve one stellar riddle, 10 more take its place. Maybe that's the real lesson here. The universe is far wilder, more unpredictable, and more wondrous than we ever imagined. Now, we'd love to hear from you. Which of these bizarre star behaviors left you the most stunned? Was it the phantom shockwaves rippling through space-time, or the stars that pulse like cosmic heartbeats? Drop your thoughts in the comments below. Let's geek out over these celestial enigmas together. If you enjoyed this deep dive into the weirdest corners of space, don't forget to hit that like button and subscribe. Every click helps us bring you more mind-bending explorations of the universe, and ring the notification bell so you never miss a journey into the unknown. Until next time, keep your eyes on the skies, because out there, anything is possible.